This is Unit 12, Electrochemistry. Lesson 2, Identifying a Redox Reaction. How do we identify a redox reaction? The objectives of this lesson: I can determine which species is oxidized and which is reduced. I can identify redox reactions, and I can determine if a reaction will occur spontaneously. Do now. So redox reactions are defined as when we have a reduction and an oxidation occurring at the same time. So these are reactions involving the transfer of electrons. And we get the name redox from that reduction and oxidation. Oxidation is defined as the loss of electrons by an atom or ion. The oxidation number goes up or increases. This means it becomes more positively charged because we are losing electrons. For example, sodium in the ground state has one valence electron. When I lose that electron, I become a sodium ion, which now is a stable 2-8 that looks just like neon. So because I lost an electron, sodium has been oxidized. Reduction is defined as the gain of electrons by an atom or ion. The oxidation number goes down or reduces, gets lower, and it becomes more negatively charged. For example, chlorine has 2-8-7 as its ground state electron configuration. To gain one electron, I will become 2-8-8, which makes a stable ion. Chlorine has been reduced because I have reduced my oxidation state from a 0 to a -1. So why is it called reduction if you gain electrons? The oxidation number is actually being reduced. That's what we are talking about. So for example, if a +2 gains 3 electrons, I become a -1. So a +2 oxidation state gaining 3 electrons is reducing its oxidation state down to -1. So for example, when we have a chemical formula, the way we can determine this is we have to assign those oxidation numbers to each element in the equation. So zinc is 0 because it's an element by itself. Hydrogen is +1 because that's the charge of the ion. After we've gone through our reaction, zinc is now a +2 charge, and hydrogen is now 0 because it's an element by itself. So because zinc lost 2 electrons, it's become oxidized. We've gone from a 0 to a +2, which means we lost electrons. So we went from 0 or neutral zinc metal to the zinc +2 ion. Each of the hydrogen ions gains an electron, and they're being reduced. So their oxidation state is going from a +1 to a 0. Therefore, those hydrogens have been reduced because they've gained electrons. So the way you can remember this is Leo the lion says grr. Loss of electrons is oxidation. Gain of electrons is reduction. So for example, oxidation's number can change as a result of a reaction. So if I have my sodium plus my chlorine to produce sodium chloride, we first assign oxidation numbers to all of our elements. So sodium is a 0, chlorine is a 0. On this side, sodium is now a +1, and chlorine is a -1. So sodium went from 0 to +1. So if I'm going up in my oxidation state, because I've lost electrons, sodium was oxidized. Chlorine went from 0 to -1, so it gained electrons, and that oxidation state was reduced. Chlorine went from 0 to -1, and it was reduced. So a second example, I've got hydrogen by itself, which means it has a 0 oxidation state. I have oxygen by itself, which means I have a 0 oxidation state. When I combine them in H2O, oxygen is now a -2, and each hydrogen is a +1. So therefore, H went from 0 to +1. So it lost electrons, therefore it was oxidized. And oxygen went from 0 to -2, which means it gained electrons, therefore it was reduced. So a tip for polyatomic ions, look up the charge on table E. This is the oxidation number. This is much easier than assigning oxidation numbers to each individual atom. So for these three things, this group of elements together, they have a total oxidation state of -1. So let's do a couple of examples. I'll do 2 with you, and then you try 2 on your own. The next slide gives the results, so you can just write those down too. Identify which reactant is reducing and which reactant is oxidizing. So because lithium is by itself, it has an oxidation state of 0. In sodium fluoride, sodium is a +1 because it's in group 1, and fluorine is a -1. After the reaction, sodium is by itself, so now it's 0. Lithium is a +1, and fluorine is a -1. So we're only going to look for a change in oxidation state. So lithium went from a 0 to a +1, therefore it lost electrons, therefore it was oxidized. Sodium went from a +1 to a 0, it gained electrons, therefore it was reduced. Leo the lion says Gur. On this side, we have sodium is 0, chlorine is 0. Afterwards, we have sodium and chlorine like this. Sodium lost an electron, therefore it was oxidized. That's our Leo. Loss of electrons is oxidation. And chlorine gained an electron. Gain of an electron is reduction. So chlorine was reduced. You tried these two on your own. And here are the answers. You can check your work. Okay, so now, are these redox reactions? The way we identify redox reactions are, we have to find if there is a change in oxidation state, and two things. We'll have both an oxidation and a reduction. So you'll have to assign oxidation numbers to everything. -2 for the oxygen, +1 for the sodium. I have a -6 for my total oxygen, therefore my chlorine has to be a +5. -1, +1, and 0. So I see a change in chlorine and oxygen. So chlorine is going from +5 to -1, therefore it's being reduced. And oxygen is going from a -2 to a 0, therefore it's being oxidized. So yes. Lithium is a 0, fluorine is a 0. I have a +1 and a negative. Both of them are changing. Lithium is being oxidized because I have a loss of electrons, and fluorine is being reduced because I have a gain of electrons. So this is a redox reaction. Magnesium is 0. Oxygen is -2. Hydrogen is +1. I have a -6 total, so then I have a +5 for nitrogen. Over here, hydrogen is 0. My oxygen is a -2, which makes my nitrogen also a +5, but then my magnesium is a +2 in this formula. Therefore, I have two changes. Magnesium is going from a 0 to a +2, and my hydrogen is going from a +1 to a 0. So yes. And finally, I'm going to put OH together as a -1, and sodium, -1 and +1, -1 for my hydroxide and a +1, a -1 and a +1. And if I look, everything is the same. So this is not a redox reaction. So there's a trick you can use to identify redox reactions. Single replacement reactions are always redox, and double replacement reactions are never redox. So here's an example equation. You can see if we do all of our oxidation states, notice zinc is going from 0 to +2, and chlorine and hydrogen is going from a +1 to a 0. So we have both oxidation, loss of electrons, and reduction, gain of electrons. Double replacements are never redox. So if I won't go through the whole process, you see there's no change. We have a +1 and a +1. We got a -2 and a -2, +1 and a +1, and a +1. They're all the same. So oxidation is when the oxidation number increases from left to right. That means I have more positive due to the loss of electrons. So if I have a number line across here, if I go from left to right, I'm increasing my oxidation number, therefore it's oxidation. If I'm decreasing my oxidation number or reducing it, then that's my reduction. So reduction is when the oxidation number decreases from left to right. I'm becoming more negative due to the gain of electrons. So this is a quick summary of everything again. So there is one thing you may have noticed. Some of the ions don't change their oxidation state, even if the other ones do. These are what we call spectator ions. It's the ion that does not have a change in oxidation number. So for example, in this single replacement reaction, copper is changing from a 0 to a +2, so I have a loss of electrons, so I have oxidation. Silver is going from a +1 to a 0, so I have a gain of electrons, and this is reduction. But if you notice, nitrate is -1. That is my spectator ion. Its oxidation state did not change. So practice. Determine which species is oxidized and reduced. And check your understanding. All right, now I can determine which species is oxidized and which is reduced. I can identify reactions, and I can determine if a reaction will occur spontaneously. Actually, this is not true, but whatever.